Today we're going to learn about periodic table and subatomic particle. First, this is the periodic table you usually get in classroom. I would definitely recommend you to keep it with you during the class and also when you do your assignments, so you get familiar with them. You don't have to memorize them, but you want to know how to use them. Okay. So the first group you see is called alkaline metal group. Let me go ahead and show you back with the table again. So this is the first group you see. Notice that it doesn't include hydrogen. Hydrogen is not part of that, okay? They have one valence electron, and then they lose that electron to form +1 ion. The next group that you see are beryllium, magnesium, calcium, strontium, barium, and radium. And they all are called alkaline earth metal group, and they have two valence electron, and they lose those two to form 2+ ion. Again, you can see that's a group 2. The next two that we're gonna talk about is all the way down here, the two group all the way end of the periodic table. So let's take a look. You got helium, neon, argon, krypton, xenon, and radon. So you guys see they are called noble gas group collectively. They have 8 valence electron. Yes, exception is helium. Helium only have 2. Okay, so that's the exception. So the next group that you see is called halogen group, and they are fluorine, chlorine, bromine, iodine, and astenine, and they each has 7 valence electron. They gain 1 more electron to form -1 ion. Okay. And you can see this is a periodic table, and you can kind of see here what else is being labeled. The green, which is on the left of the periodic table, they're metal. Exception is again hydrogen. Hydrogen is a non-metal, just like carbon, nitrogen, oxygen, fluorine, neon, helium, right? All that stuff. Now, the thing between the metal and non-metal is called metalloid, which is shown by this blue, which is boron, silicon, germanium, arsenide, antimony, tellurium, and astenine. And depending on the textbook, sometimes they do include polonium as part of the metalloid, so we need to watch out for that one. All right, moving on. Lanthanide and athanide series. So you can see the top one is lanthanide, the bottom one is athanide. They are the other two groups on the periodic table. These are rare earth metals, and some of them, so we usually don't have much talk about them in the chemistry, except when we get to the nucleochemistry, we'll talk about that one. Okay, so the next few you want to know is these. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodines. These 7 of them are called diatomic element. That means whenever they are alone, they are actually in a pair of 2. So that means when we say oxygen, O2, when we say hydrogen is H2, so therefore you got. Okay, now there's another mnemonic device to remember with this, but I never really use them. The way that I remember is they kind of look like number 7. If you look at the periodic table, right? Nitrogen, oxygen, fluorine, chlorine, bromine, they kind of look like number 7, and there's the other one right there that is floating on that side. And then together there are 7 elements. So, yeah. All right, moving on. The next one that you should know is how to read the periodic table. So the way you read the periodic table is quite simple, right? The top number here is the proton number, the number of protons, and then you have element symbols next, which is H, and the hydrogen, which is a name, and then on the bottom is an average mass of the element. So that means is all the elements of the hydrogen that is available on Earth, and their mass is averaged. So they have 1.01. The next one you want to know is how elements are arranged or composed. They are made out of electrons, which has a negative charge, proton, which is a positive charge, and then neutron, which is no charge. And then proton and neutron are together make up something called nucleus, and they're in the center of the atoms. Electron orbit or revolve around the nucleus. Okay, some of the fun things to know. Protons, they are positive charge. Their mass is approximately 1 AMU or 1 atomic mass unit, and it is the identity of the element. So what does that mean? That means all the hydrogen, for example, will have 1 protons, or the helium will have 2 protons, and so forth. So if you're looking at this, for example, here, we know that all the nitrogen in the world will have 7 protons, all the oxygen in the world will have 8 protons, so forth, right? So neutron is a subatomic particles with no charge, and it has mass approximately of 1 AMU again, and it can be changed. Its change can vary within the same elements, meaning that is still the same elements, but now their mass is changed, and this is called isotope. For example, hydrogen will have 3 different versions. They can either have no neutrons, or have 1 neutrons, or 2 neutrons. Okay, nucleus is basically where proton and neutron are both together. This is where they have the mass of the elements is come in, and nucleus is positive charge because proton has plus side and neutron has no charge. Electron are the negative charge particle. We can say its mass is approximately 0, not really, but it's close enough. Changing this will change the charge of the ion. So from neutrals to become ion charge there. So for example, hydrogens, neutral would be they have the same number of proton and electron. So if you gain an electron, it's become negative because electron is negative charge. If you lose an electron, you become positive charge because you lose the negative, okay? That's just a little funny jokes. So you should know that protons, neutron, and electron are all subatomic particles. All right, so how to calculate them? Atomic number is basically number of proton, which is the same as the number of electron if it's the neutral element. Now, if mass is just proton plus neutron, okay? Ion will have different number of electrons. You will never, ever, ever lose protons or gain protons. If you lose or gain protons, you will no longer be the same elements. Okay, so let's go ahead and try to figure this one out. Again, I will highly recommend you to pause this video and go ahead and grab the periodic tables to figure out, to see if you can figure out what is going on here. Okay, so hopefully you have, go ahead and start it out already. Element name, this will be helium. I'm not gonna write for the rest of the element name because the element name is right there. It will say underneath the periodic table right there. Okay, what I'm gonna do is I'm gonna fill out the rest. Proton number is gonna be 2, right? Because it's right there, it will show up there. Electron number is also 2. I'm not gonna go ahead and write the rest because protons and electron are the same in this case because we're assuming that it is the same element, right? I mean, the neutral atom, sorry. So that's what it is. So I'm just gonna go ahead and line them up. These are all here, right? So that would be 8, 8, that would be 9, 9, that would be 24 and 24. All right, so what next? Okay, the number of neutrons. So how are we gonna tell the number of neutron? The number of neutron is basically mass minus the proton number, right? So the mass in this case, let's start with the mass first. I'll go ahead and write the mass first. Mass is 4, okay? So that means this is gonna be 4 minus 2, right? Which in this case is gonna be 2. So we know that this is gonna be 2, okay? Again, the masses is down here. Okay, so that would be the mass. Okay, that would be the mass. Okay, so this is what you would get if you have done the math. All right, moving on to the next slides. Okay, let me clear those. So there are different forms of the same elements. Okay, this is where the average mass come in. And then to do the average mass, basically what you do is you get the percentage of each element mass, and then you multiply by the percentage with their mass, and then you add up together. So in this case, you can see that 10, boron 10, B10 is about 19.9%. So therefore 10 times 0.199, right, which is the 19%. And then of course, the 80.1% is boron 11, so 11 times 80.1, actually I should say 101, so I'm missing the little 1 right there. Yeah, that is not supposed to be disappear. That is supposed to be with that. And then you're supposed to do the math with it. And then when you add, you should get certain number, and that should be close enough to this. So I might have messed up the math in here. All right, so the next part is this. I want to make sure that you're understanding this part. So whenever you see the name that say boron 10, carbon 14, right, hydrogen 2, whatever it is, the number that come after the elements, if they only ever give you one number, that number, unless they says otherwise, is the mass of that element. Okay, they don't have to give you proton number, because the moment they tell you boron, you know that its proton number is 5, because every boron in the world has 5 protons. Okay, so therefore they don't need to tell you the proton number. If there is only one number ever given, that number is mass. All right, so moving on. Isotopes. So again, isotope is the same elements because they have the same number of protons. The only difference is they have different number of neutron, which also means this is the different mass. Okay, they will have different mass. So for instance, here you will see protium, deuterium, tritium. They all has different mass. Hydrogen 1, hydrogen 2, hydrogen 3, right? Therefore, so on. All right, moving on. Let's go ahead and try to fill this again. So this time you're gonna try to pause this video and you're gonna try to do that. And then you can come back and match the answer. So these are your answers. Notice that my neutron number are approximately. That's because I did not give you exact mass. You're working on the average mass. So for this kind of question, usually they will give you exact match. Like, so for example, they will say like aluminum 27, or they might say aluminum 26, aluminum 25, right? They might give you a specific number of aluminum, and so you'll use that mass to find out the neutron. So in this case, like I said, because I give you the decimal mass, I just simply rounded them so that I get the better neutron number, so that I don't have like partials. All right, that's all for this lesson. I will see you in electrochemical configurations.